Okay, which choice best describes data from the table that will support the researcher's claim? So this is strength and weakens, command of evidence, where we need to use the table to support the claim. So let's read the paragraph and figure out exactly what the claim is we have to support. Alicia, these researchers recently examined several plots within a diverse plant community in southeast Spain. The researchers calculated that if individual plants were randomly distributed on this particular landscape, 15% would be with other plants in patches of vegetation. Okay, so only about 15% would be with other plants if they're random. They counted the number of juvenile plants of 5 species growing in patches of vegetation and the number growing alone on bare ground compared to those numbered to what it would be expected if the plants were randomly distributed. Okay, so if they looked in the patches of vegetation, they should have found 15%, right? And versus those alone, which I guess would have been the other 85% or so. Results based on this, they claim that the plants of these species that grow in close proximity to other plants gain an advantage at an early developmental stage based on these results. So again, if it's randomly distributed, they would expect 15% in and among the other plants. What do we actually get here? The percent found in vegetation is basically 60-ish% across the board, much higher than you would expect. So these are youth plants, though. This is not, the claim here is that individual plants generally, these are juvenile plants. So maybe when they're young, they have to be interspersed among other vegetation to gain some advantage to help them survive. Okay? So what data from the table helps us support that? Well, it's the fact that it's 60% for all the species that are juvenile plants, much higher than you would expect from random distribution. They seem to necessarily need the extra vegetation for support. So for all 5 species, less than 75% of juvenile plants are growing in patches. No, it's not that it's less than 75, it's the fact that it's 64 times the 15%. B, the species with the greatest number of juvenile plants growing patches. It's not about which species had the greatest. That's not the right answer either. For Lebantis maderi, the percentage of juvenile plants in patches of vegetation was less than what would be expected if plants were randomly distributed. No, because that expectation of random distribution would have been 15%. All of them are well above that. So this is, not true. That's wrong. For each species, the percent of juvenile plants growing patches of vegetation was substantially higher than what would be expected if plants were randomly distributed. That's the idea. They're all 60%, not 15%. Sometimes the conditions and the answer are easier to assess, which I think is true in this case. Okay, let's check the question prompt. Which choice best describes the table from the data that supports? So this is strength and weakens, command of evidence. And we need to use the data from the table. We need to support, not weaken, the hypothesis. So let's read the paragraph and get a sense of what's going on and what the claim or hypothesis is. When hibernating, Alaska marmots and Arctic ground squirrels enter a state called torpor, which minimizes the energy their bodies need to function. So it's kind of hibernation, basically. Often a hibernating animal will temporarily come out of torpor, called an arousal episode, and its metabolic rate will rise, burning more of the precious energy the animal needs to survive the winter. Alaska marmots hibernate in groups. So both of these animals hibernate, this one in groups, and therefore burn less energy keeping warm during these episodes than they would if they were alone. A researcher hypothesized because Arctic ground squirrels, who we can presume hibernate alone, not as groups, they would likely exhibit longer bouts of torpor and shorter arousal episodes. So I want to find, does the table support squirrels having longer bouts of torpor? The squirrels have less torpor bouts, but are they longer? Their duration is 16, and that's compared to 13 for the marmots. And that would be longer bouts of torpor, yes. And shorter arousal episodes, so their arousal episodes were 14.2 hours compared to 21.2 hours, which is shorter. Okay, that looks to be the data that's going to tell us. Let's check the answer choices. No, tried to predict the answer from the table before I look at the answer choices. The Alaska marmot's arousal episodes lasted 4 days, while the Arctic ground squirrel's arousal episodes lasted less than a day. No, that's not telling us any detail from the table. There's no information from the table. The Alaska marmots and the Arctic ground squirrels both maintained torpor for several consecutive days per bout on average. Yeah, but that doesn't say the comparison. Our claim is there are longer bouts of torpor for the squirrels. The Alaska marmots had shorter torpor bouts. Yes, so if the squirrels had longer, the marmots have shorter. That looks to be good, consistent with our condition. And the duration per bout, that's the right data. And longer arousal episodes, so the marmot has the longer arousal episode, which is to say it had the squirrel had the shorter arousal episode. So this is the same conditions, they're just flipping it around. Instead of saying squirrel, shorter arousal episode, marmot, longer arousal episode, same thing. Then the Arctic ground squirrels did. This is going to be our answer. That is correct. D, the Alaska marmots had more torpor bouts than arousal episodes. No, it's not a comparison between arousal episodes versus torpor bouts. That's not the right answer. So these are all wrong. C is the correct answer. Okay, let's read the question. Which choice best describes from the table the data that support the researcher's conclusion? Okay, so this is strengthens, weakens. I need to support the data with information from the table. Researcher and colleagues monitor individuals' velocity and surrounding crowd density. As a group of study participants walk through a space, navigated around an obstacle, participants rated how congested it seemed before the obstacle, after the obstacle, and overall. We've got before, after, overall, and we have the two measurements of density and volume. Okay? And the researchers correlated these ratings with velocity and density. Correlations range from -1 to uncorrelated, 0 is no correlation, or negative correlation, perfect, to 0, no correlation, 1 is perfect correlation, with greater distance from 0 indicating greater strength. So it's either perfectly negative, perfectly positive, or no correlation, 0. The researchers concluded that the correlations with velocity are stronger than those with density. Okay, if the correlations are higher for velocity, the velocity numbers will be closer to 1 or -1. Is that true in the data? The density before, after, about 0.7 to 0.8. The velocity, these are the 0.85s to 0.95s. These are closer to -1 in this case, which means they're negatively correlated, but they're more negatively correlated, better negative correlation. So let's see what answer mentions that, because that would support the conclusion that velocity is in fact stronger correlation. Correlation between congestion ratings before the obstacle density is further from 0 than between overall congestion, and that's just simply not answering our question. The correlation between congestion ratings before the obstacle and velocity is further from 0 than the correlation between congestion overall. Okay, it's not between before and after and overall. That's just the wrong comparison. The idea is that across all of them, before, after, and overall, that number of correlation must be closer to 1 or -1 for velocity than it is for density. Minus 0.85 is closer to -1 than 0.7447 is to 1. So for each of the ratings, the correlation with velocity is negative. Well, the correlation with, no, it's true, they're positive and negative, but that says nothing to answer our question. For each of the 3 ratings, correlations with velocity are further from 0 than the corresponding correlations with density. Yes, for each of the ratings, before, after, overall, the velocity correlations are farther from 0 than the density. This is absolutely correct. Okay? Note some of these answer choices are true to the table, but again, they're not relevant, which is often what we look at when we look at the table quantitative command of evidence questions. Some answers will be true to the table, but it also has to answer the question, be relevant, okay, to the claim.